So the title of today's lecture is Geometry, Word Problems, and Radicals. And what you'll notice, so I've given you this geometry formula sheet, which I'll show the video here too. So if you're looking at this, you can know what to look for in your notes. What you'll notice is a lot of these formulas involve squares or multiplying things together. And so square roots are fairly common in word problems that involve things like finding the area of a geometric figure, or, and the first one we're going to talk about, using the Pythagorean Theorem in geometry. So the Pythagorean Theorem is going to be kind of our first type of geometry word problem. And there's a lot of ways that you'll see this in word problems. You always know that they're talking about the Pythagorean theorem when they're talking about, or when a problem is talking about, a right triangle. So when two things meet at a 90-degree angle, two legs of a triangle, right, they form a right triangle. The other thing to know, in a triangle, the hypotenuse, which is the longest side, is always the shortest distance between the 2 points that it connects. Okay? So the shortest distance between here and here is this side of this triangle. There's no shorter way to get from here to here. And so sometimes you'll see Pythagorean theorem problems phrased as, what is the shortest distance between, this point and this point? If Jimbo walks 10 miles north and Sally walks 9 miles east, what is the shortest distance from Jimbo to Sally or something like that, right? That could be a Pythagorean theorem because those three distances form a right triangle. Okay, what does the Pythagorean theorem say? Well, it says if we call the three sides of a right triangle A, B, and C, C being a hypotenuse, then A squared plus B squared will equal C squared. So the length of this side squared plus the length of this side squared will always equal the length of this side squared. And you can do a lot of things with the Pythagorean theorem in word problems, right? Or in other types of problems. One thing you can do is, someone can give you three lengths. I could say, are these three sides, 3, 4, 5, are those sides of a right triangle? How would you find out if 3, 4, and 5 are all sides of a right triangle? What could you do to figure that out?
Square 2 of them and see if it
Yeah, so we would take these two. Can I pick any two? I have to pick the smallest two, right? So what I'm imagining is, if these are sides of a right triangle, 5 is going to be my hypotenuse. So that means this one squared plus this one squared would have to equal this one squared. So does 3 squared plus 4 squared equal 5 squared?
Yes.
And in this case, we have 9 plus 16 equals 25. That is true. So these are the sides of a right triangle. 3, 4, and 5. Okay? But if I had given you different numbers, like if I had said 3, 4, and 6, are these the sides of a right triangle?
No.
Then we would have had 9 plus 16 equals 36. That's not true. So there can never be a right triangle that has those three sides. It's impossible, because they don't fit into the Pythagorean theorem. Okay, so some of the problems you'll see are just checking to see, does this triangle meet the requirements of a right triangle? In other words, does it fit the Pythagorean theorem? Another type of problem you might see is, let's say we have a point here, right? And we say something like, so-and-so walks 6 miles east. And then so-and-so walks 8 miles north. And the question would be something like, how far apart are they? There's a lot of ways questions like this can be phrased, but what I would recommend doing if you see problems that you think might fit the Pythagorean theorem is you draw a diagram. And if you draw a diagram and it looks like a right triangle, that's when you're going to know it's the Pythagorean theorem.
So then you can do like 8 squared plus.
Yeah, yeah. So let me give you an example of a problem that that this might fit into, right? Let's say Lucinda has 2 pet squirrels. They escape. And one of them runs 8 miles north. The other runs 6 miles. And then the question would be something like, how far apart are the squirrels? There's a lot of ways you could phrase that, though. It might say something like, if Lucinda catches the squirrel that's run 8 miles north, how far does she have to walk to find the one that's run to the east? Or, anything. But the idea is how far from this point to this point. All right, so we would draw this diagram, right? We could draw a little squirrel running. Right? And he's running that way and he goes 8 miles. So the key here is we recognize 90 degrees. We have 2 sides of a right triangle. Which 2 sides do we have? We have the 2 legs in this case. So in a triangle, the hypotenuse is the longest side. That's always across from the 90-degree angle in a right triangle. The other sides are called the legs. So A and B are the legs. So in the Pythagorean theorem, we have A and B as our 2 sides that we're doing. So we're going to do something like 8 squared plus 6 squared equals C squared. We can solve this. 8 squared is 64 plus 36 equals C squared. And this is why I'm teaching you guys these right after you've learned all the radical rules. It's because now you'll start to see radicals. Right? So 64 plus 36 is 100. That equals C squared. So we need to take the square root of both sides. And we'll see that C equals 10. So our answer to this problem would be they are 10. All right. Any questions about that? So you'll also see these sometimes in other formulas, right? Now, the Pythagorean theorem is so useful because if you look at these other formulas, a lot of things in geometry are defined by having right angles. So one example of that is if we're talking about a square has 4 right angles, right? And so if we cut a diagonal across a square, this half becomes a right triangle, and this half becomes a right triangle. Right? So you could see a problem like Noah is planting a square garden. It doesn't even have to be square, it could be rectangular. I don't know if we'll have time to do 2 problems, but we'll see. He measures one side of his garden. It is 10 meters. If he wants a hose that can reach from one corner of the garden to the opposite corner, how long of a hose does he need? So he's making this garden, right? He measures it out because he's going to buy a fence. He has 10 meters on every side of his garden. Now he realizes, okay, now I need to buy a hose that can reach every point in the garden. So it can reach from one corner all the way to the other corner. And that way I can water my garden. So that's a diagonal across this garden. Right? We know that since it's a square, that both sides must be 10 meters. Because in a square, all sides are equal. And so what is the length of this hose that reaches from this corner to this corner? Well, since we have a right angle here, we can use the Pythagorean theorem to find out. We know that this squared plus this squared has to equal this squared. So in other words, 10 squared plus 10 squared must equal, we'll call it h for the hose squared. Okay. So we have 100 plus 100 equals h squared. We have 200 equals h squared. And so h, if we take the square root of both sides, equals the square root of 200. Now this is where simplifying radicals comes in, right? We don't want to leave this as the square root of 200. We want to turn that into the simplest form we can get it. So what is the square root of 200 in its simplest?
100 times 2.
Yeah, so square root of 100 times 2, which is 10 square roots of 2. And then you could turn that into a sentence. I don't want to write any more sentences right now, but it would say something like Noah's hose would need to be 10 square roots of 2 meters long, right? Or you could type that into a calculator and round your answer, right? Round up a little bit. You would need a hose that is 15 meters long, 14.2 meters long, or something like that. Whatever you get. What?
It'd be like 11 point something.
Yeah, I think the square root of 2 is like 1 point, 1 point, I can't remember now. 1.236, is that it? Something like that. No, I have to look it up. No, 1.414. Oh yeah, of course, 1.4. All right. And then sometimes you'll see problems that bypass all these words altogether and just go straight for the formula. I don't know if these are even really considered word problems, but you could see a problem that says this. I have a rectangle. This side of the rectangle is 4 square roots of 2 feet long, and this side of the rectangle is 3 square roots of 6 feet long. What is the area of my rectangle? So the area of a rectangle is one side times another side. And in this case, the area would be 3 square roots of 6 times 4 square roots of 2. And now we're going to need to combine those into 1 square root. So the 3 times the 4 is going to be 12. Square root of 6 times 2. As I'm doing that, I'm looking for those factors that are in common. And I notice 6 has a 2 in it. In fact, 6 is 2 times 3. So now I'm going to pull out my 2. I have 24 square roots of 3 as my final answer. That is the area of this rectangle. Another one that's a little tricky maybe. Let's say they said you have a parallelogram, and there's actually a couple of shapes that you could see a problem like this. If I have a parallelogram, if you look on your sheet, the height of a parallelogram is, from the top to the bottom in a right angle, right? And it's drawn like that on your sheet. That also means that this is a right angle. So if I said find the height of a parallelogram with sides I'm just going to label it actually. Find the height of this parallelogram. Right, so let's say they gave you this side, and that side was 15. And then they gave you this part right here, and that part was 9. how would you find the height of this parallelogram? What kind of shape do we have in there?
Oh, we do
Yeah.
base times height like
It's a right, this is a right triangle. What do we know whenever we see a right triangle? What do we automatically want to think?
A squared plus B squared.
Yeah,
is
Pythagorean
C squared.
Theorem. A squared plus B squared equals C squared. Jumps into your head. Right triangle, Pythagorean Theorem. You're almost always going to need it when you see a right triangle. What's different about this, though, than the other problems I gave you with the Pythagorean
Give us
Theorem?
the C, not.
Yeah, I gave you the C, so I gave you one of the longest sides. So it's really important to notice which sides you have. Because if you plugged it in like this, 9 squared plus 15 squared equals C squared, you're finding a totally different triangle. Instead, you want to recognize, here are my two legs. One of the legs is unknown, so let's call this B. I'm going to have 9 squared plus B squared equals 15 squared. Now you have to remember those rules for solving radical problems, right, or exponent problems. I have to get this alone before I take the square root. One of the most common errors people make is they go, oh, I'll just take the square root of everything. So 9 plus b equals 15, square root of everything. But that doesn't work. Because remember, square roots distribute across multiplication, not across addition. So the square root of a plus b, or the square root of all this, does not equal the square root of this plus the square root of this. That is not true. So first, I have to get this alone. Okay. Yeah, so I'm going to subtract 81 from both sides. Let's first simplify these numbers. 9 times 9 is 81 plus b squared equals, what is 15 times 15? Yeah? Okay. 225. Subtract 81 from both sides. And then we have b squared alone. Right? And before we find b, we have to find b squared. That's going to equal 5 minus 1 is 4. Borrow from the 1. 12 minus 8 is 4. 144 equals b squared. Take the square root of both sides. And b equals 12. So the height of this parallelogram is 12. And we found that using the Pythagorean Theorem, which sounds a little weird at first, because we're talking about a parallelogram, not a right triangle. But there are right triangles within a lot of these shapes. And that's one thing you can notice. Whatever unit I told you. Inches. Let's say inches. So the height would be 12 inches. All right. I can't, it's impossible to go over every problem that you might see because it'll just be worded in different ways, right? And you might see different formulas. So I think we're going to stop there. And